Continuing with 5.1, we're going to go on to dividing monomials. So as we all know, multiplying and dividing are opposites. And so when we think about using the quotient property for dividing monomials, it's going to be the opposite of the product property. So in the product property, we added the exponents when the bases were the same. For the quotient property, we are going to subtract their exponents if the bases are the same. Let's explore this just using basic numbers again. Let's say we had 2 raised to the 5th divided by 2 raised to the 3rd. So just explaining this a little bit further, we have a base of 2 and a base of 2. So if their bases are exactly the same, what we can do is we can just subtract their exponents. We'll show you this using, first simplifying it how you would instinctively, and then doing it using the quotient property. So instinctively, you would say the numerator is 2 raised to the 5th, which is 32, divided by 2 raised to the 3rd, which is 8. And then we all know that 32 divided by 8 is the number 4. So instinctively, I'm sure this is probably how you would do it. If we were to use the quotient property, what we could say now, and this is what works is so beneficial for using with variables, is that 2 raised to the 5th divided by 2 raised to the 3rd. Once your bases are the exact same, you can subtract their exponents, so 5 minus 3, which would make 2 raised to the 2nd power. The base stays the same, and then you subtract the exponents, 5 minus 3, equaling the number 2. And so then 2 squared equals 4. So as you can see, you can do it either way. It doesn't matter because you get the same answer either way. But as we know, we can do this method using variables. So because we can't use this one with variables, we're going to use the quotient property, which means we're going to subtract their exponents. Such as in this one, we have x raised to the 5th divided by x cubed. They both have a common base of x. So my base is going to stay x, and my exponent is going to be the difference of 5 minus 3, x squared. And there is my answer, x squared. Number 7, we have x squared divided by x to the 7th. The way that we're going to look at this is, are there more x's in the numerator or are there more x's in the denominator? We can look at this as saying x times x divided by x times x times x times x times x times x times x. 1, 2, 3, 4, 5, 6, 7. Got them all. So if you look at this, we could say that anything divided by itself is 1. So x divided by x cancels and it just makes a 1. X divided by x cancels, it just makes 1. So we have 1 in the numerator, and we have 1, 2, 3, 4, 5 x's in the denominator. X times itself 5 times is x raised to the 5th. So my answer is 1 over x to the 5th. Now on a test, I certainly don't expect you to show all this work. What you could just do is you could just say, well, there's more x's in the bottom. 7 is a bigger number than 2. So just subtract 7 and 2 using the quotient property. 7 minus 2 is 5, so it's x raised to the 5th. However, it's not x raised to the 5th in the numerator. There's more x's in the denominator, so there's x to the 5th in the denominator and the 1 in the numerator. So there is our answer for that one. I hope that makes sense. If you need any more work with that, we are going to be doing 3-4 more problems on this quotient property, and certainly come and ask me when you have free time on your own as well. Moving on to number 8, we have x raised to the negative 3rd divided by x raised to the negative 4th. So we know that we're going to use the quotient property because we're dividing. However, let's simplify this first. What I told you in last lesson is that whenever you have a negative exponent, you can move it from the numerator to the denominator and just change the sign on that exponent. So we can say that this exact same thing is x to the 4th divided by x to the 3rd. The x raised to the negative 3rd went downstairs to make it x raised to the positive 3rd, and the x to the negative 4th went upstairs to make it x raised to the positive 4th. Now that we have positive exponents, this becomes quite simple. You have more x's in the numerator, so it's going to be x. 4 minus 3 is x raised to the 1st, which is just x. You can have x raised to the first if you would like to. I certainly won't dock you for it if you do have it, but it's not necessary. The answer is just x. Moving on to number 9, x raised to the negative second divided by x cubed. What I might do on this one, and there's a couple different methods on how you can solve a lot of these, so if your method works for you, certainly use that one. But I might say I like working with positive exponents, so I'm going to move this x raised to the negative second downstairs. If that's the case, all I have left in the numerator is 1, and I have x cubed now multiplied by x squared in the denominator. When I move that x raised to the negative second to the denominator, it's now multiplied by the x cubed. So now we have 1 still in the numerator, and with multiplying monomials with common bases, I would add their exponents, making it x raised to the 5th. 1 over x raised to the 5th. And that is my answer for number 9. Number 10, I'm dividing once again. Now just as we multiplied the numbers together with monomials, we multiplied them and then we added their exponents. Same thing, when we divide their coefficients, we actually do what's written. So we have a negative 6 divided by 1 is just the number negative 6. And now we have x to the 4th divided by x raised to the negative second. Once again, I would probably move this to the numerator to make it x raised to the positive second. Now you have common bases of x and x, so we're just going to add their numerators of 4 plus 2, making it a negative 6, x raised to the 6th. And this is our answer here. I know that some people in the past, they've wanted to maybe move this to the denominator and make it a positive 6x raised, a positive 6x to the 6th, but you cannot do that. You can only do that when your exponents are negative. And as you can see, our exponent is a positive 6, so we're going to leave it right where it is. So our answer, once again, a negative 6, x raised to the 6th. Our last one of this type, going to be using a few different properties. We have a quotient inside the parentheses, and we have another exponent on the outside of the parentheses. So there's actually 2 ways that you can do this. You could square everything first, so square the negative 2, square the x squared, square the y to the 4th, square the 4, square the x to the 5th, and square the y. As you can see, that might get a little bit messy. I think it's more inefficient to do it that way. I wouldn't recommend it. What I would recommend is simplifying the parentheses first, and after simplifying the parentheses, then square everything. So let's just worry about this section right here. So we have a quotient, a negative 2 divided by a positive 4 is a negative 1/2. And then we have our common bases of our x term, x squared and x to the 5th. As you can see, there's more x's in the denominator. So when there's more x's in the denominator, that's where my x's are going to stay after I subtract. So 5 minus 2 is x raised to the 3rd power. And now I have my y to the 4th divided by y raised to the 1st. So there's more y's in the numerator in this case. So if there's more y's in the numerator, I'm going to subtract 4 minus 1 as being y cubed. So it's a negative 1 y cubed over 2x squared. And there's my answer on that one. Be sure to let me know if you have any questions on this when you have free time in class or before school and after school. I hope this all made sense to all of you.